Thank you very much. I tend to be a loud speaker, so if it starts to get too noisy, they'll turn it down in the back. But first I want to thank Craig and Linda for the invitation to come. I want to thank AgMart for sponsorship of my trip here. And most I want to thank the dairy sheep producers that we've met so far and their great hospitality. And we look forward to meeting some more before we leave. It's been absolutely a fabulous trip so far. As you all know, you have a beautiful, beautiful country, and it's a great place to be. So we'll get on with it. I'm going to present over the next few minutes the dairy sheep, some of the highlights of dairy sheep research that we've been involved with at the University of Wisconsin-Madison. And I've listed my very close colleague, Yves Berger, who's the manager of our sheep research farm. Both of us are retired now, but both remain somewhat active in the dairy sheep sector. A little bit of background. I'll go through this quite fast. You're all well-traveled, geographically astute people. So there's Wisconsin. We're in the upper Midwest around the Great Lakes with the Mississippi River on our western boundary. We have a land area that ranks us 23rd among the 50 states, so we're just a little smaller than average, or a little larger than average. We have about 6 million people, so we're a little below, a little above average again in population. Median household income is about US $55,500. Ranks us 28th among the 50 states, so a little below average in income. We aren't a wealthy state. Our slogan, every state has its slogan, like Idaho is famous potatoes. Wisconsin is America's dairyland. Agriculture is very important to the state of Wisconsin. It's an $88 billion industry. It's estimated that it employs over 413,000 people. Where does it rank first? We're first in the nation in cheese production. It's estimated that if Wisconsin was a country, we would be fourth in the world in cheese production. So we're a major cheese producer. And then some other things that maybe aren't all that important. Green beans, we call snap beans, cranberries, ginseng. I remember a few years ago when I was at a meeting in Beijing, I went into the local supermarket and there was Wisconsin ginseng on the shelves. We're first in mink, dry whey production. We're first in dairy goat numbers and the amount of goat milk processed, and corn silage. We're only second in number of dairy cows, even though we're first in cheese production. California surpassed us in dairy cow numbers a few years ago. But the dairy industry is the important industry of the agricultural industry in Wisconsin. We have, including goat, sheep, and cow dairies, and of course the vast majority are cow dairies, 8,800 dairy farms. We have about 1,200 cheese plants just in the state of Wisconsin, some of them producing commodity cheeses, most of them small plants producing specialized artisan cheeses. We produce over 600 varieties, different varieties of cheese, 1.5 billion kilos of cheese produced annually in Wisconsin, and the dairy industry returns about $43 billion annually to the Wisconsin economy, which accounts for about 50% of the entire ag economy. A little closer look at Wisconsin. I'm located at the University of Wisconsin-Madison, and our Spooner research, where the dairy sheep are up here in northwest Wisconsin. This is about 400 kilometers distance. And this is one of 13 ag research stations that the university has spread around the state. A little bit about the spooner, so you'll get an idea of the environment that these sheep live in. The high average monthly temperature occurs in July, and it averages 28 C, which is fairly warm, and it's warm and humid in the summer. But then we have the other extreme in January and February. The average low temperature is minus 14 centigrade, so tremendous variation in temperature throughout the year. We have about 760 millimeters of rainfall a year, but we also have over 1,200 millimeters of snow during the winter. Our sheep don't see green grass until May, which would be, the equivalent of November here. So we do a fair amount of stored feeding of our sheep. This is our very modest dairy sheep farm. Here's an aerial view. This is our barn that we use for lambing. This is our milking parlor, which I'll show you in a minute, built here on the end. During the winter time, the ewes are outdoors in these shelters, so they're exposed to the cold and the snow, but they can get in out of the weather if they wish. It's the only, or it was, the only dairy sheep research farm in North America. However, I announced that I was going to retire in January of 2017, and at that time, much to my chagrin, the university decided that they had other priorities other than hiring a new sheep scientist, and so the College of Agriculture made the decision to close the unit down, and so we dispersed the ewes in October 2016. So we were the only research and development organization for dairy sheep in North America. Now there is none. So I'm glad to see the interest in dairy sheep research here, because our North American producers are going to be looking for new sources of technology. Before I get into the research, as anybody that works at a university knows, that it's the people on the ground that at the farm that collect the data, that manage the sheep, that are important. It's the graduate students that design the experiments and analyze the data that get the results put through the door. And I've been very fortunate to have in the dairy sheep group 4 PhD students, Dr. Brett McCusick, who did a lot of lactational physiology work. All of his work is published in the Journal of Dairy Science. He's now Food and Drug Administration regulator, or deals with FDA for big pharma companies. Claire Michelet-Eunice, who was our extension, after she finished up, was our extension dairy, goat, and dairy, our sheep and goat extension specialist. Maristella Rovai, who Adrian mentioned in his presentation yesterday, was a postdoctoral student that came to us and spent 2 years with me after finishing up with Gerardo Caja in Barcelona. She's probably the world's expert on udder morphology of dairy ewes and ultrasounding of dairy ewes. She's now the extension dairy specialist at South Dakota State University. My last graduate student, Dr. Tom Murphy, is the one that has done the genetics work on our sheep flock, and he's now the new sheep researcher at Montana State University. So, and his work is published in the Journal of Animal Science. Maristella and Claire's work has been published in the Journal of Dairy Science. Okay, this is a slide that we'll start with to give hope to those people that are starting out with relatively low production. We'll take the red line here. This is the milk production. I'll apologize, it's in pounds over here. We milked our first ewe lambs in 1996. So our first 2-year-old ewes were milked in 1997, and they had 250 pounds, something less than 110 liters of milk. And up here in 2010, and it's continued about this level, we're up to a little over 850 kilos or 300 pounds, 390 liters of milk. So as I go through the presentation, there's lots of things that we did to get from here to here. One of the main things was to increase the proportion of dairy breeding in our sheep, because we started with meat sheep, but we also did several management interventions that got us to that level. So we're quite proud of the level of production that this flock has obtained. Okay, dairy sheep breeds. How much better are dairy sheep breeds than existing meat wool breeds? Are there differences in performance between the dairy breeds? Our very first dairy sheep were 2 F1 rams that came in from Canada. We weren't allowed to bring, at this time, semen into the U.S., but Canada was a bit more relaxed, or maybe I should say reasonable, in their approach to importation. And so our very first dairy ewes that we produced out of these rams were just a quarter East Frisian breeding. This is our very modest parlor. It's a double 12 cast system with a swing over system with just 6 milking units. We can run about 140 ewes per hour through this little system. As we got into this more, we would have liked to have had a double 24, but we never got to that point. Starting out then with some of the data. The very first comparison we had were Polled Dorset cross ewes compared with our very early East Frisian cross ewes. These were only a quarter or a half East Frisian. And you can see the increase in milk production, almost double milk production by having as little as a quarter or a half East Frisian breeding in these sheep. So the answer to the first question is pretty easy. If you're going to milk sheep, you need to milk dairy sheep. After we brought in some of the East Frisian, we were able to get a small sample of Lacone genetics, and they came in to our station in 1998. And purebred East Frisian genetics became available after 1995. So we took this small sample of Lacone genetics, the East Frisian semen we had, and we just started breeding with those 2 breeds of sheep. So Tom Murphy has completed a complete genetic analysis of our data set, and I'm almost embarrassed to put this data set up here after learning about how many sheep are milked in some of these large units here. Our total data set from 1994, sheep born in 1994 through 2014, included ewes from 101 different sires, about 5,500 lambing records from about 2,000 total ewes. Our flock at any one time were milking 270 to 300 ewes, and we had 4,700 lactation records from 1,700 ewes. Okay, this one is a little messy, so I'll take a little bit of explanation on this. This is, think about this flock of ewes. There are various proportions of East Frisian, Lacone, and non-dairy sheep. We've got everything from total non-dairy to high percentage East Frisian, non-dairy, high percentage Lacone, half Lacone, half East Frisian, all the various permutations. And by doing somewhat of a regression analysis, looking at, say, the various proportion of East Frisian breeding, we can predict what a purebred East Frisian ewe would produce, and we can predict what a purebred Lacone ewe would produce, and a purebred or straight-bred non-dairy sheep. We lump them all together. And so coming across here, these comparisons are a comparison of East Frisian with non-dairy, Lacone with non-dairy, and of course with both of the dairy breeds we get a significant increase in milk production over the non-dairy. We get a significant increase in fat yield, protein yield. You'll note here that the percent fat and protein is less in the dairy breeds, tends to be less in the dairy breeds than it is in the non-dairy sheep. Non-dairy sheep don't produce much milk, and they've got high components. The one exception here is this is non-significant, so the Lacone had about the same percent fat as the non-dairy sheep. Somatic cell count, and then this is number of lambs born per ewe. The Lacone was not any different from our non-dairy sheep. The East Frisian produced about 18 more lambs per 100 ewes lambing compared with the non-dairy. Now, what we're interested, of course, is the difference between the East Frisian and Lacone, and wherever I've got red in here, it means that there's a significant difference between the East Frisian and the Lacone, and I've highlighted in red the one that has the highest. So we've got about 38 more kilos of milk out of our East Frisian ewes than our Lacone ewes. I want to mention that our sample of the Lacone is only 6 rams, 3 rams from the UK that some way mysteriously swam the English Channel to get to the UK. Came from Ian McDougall at Malvern. And there is one Lacone farm in Ontario, over on the Quebec border, a Swiss immigrant, Joseph Regley, is a veterinarian, and he brought with him from Switzerland East Frisian embryos and Lacone embryos. So we have 3 rams from him. But realize that the Lacone group in France was making on average about 6 liters of genetic progress per year. In recent years, where they've put more emphasis on fat and protein and udder conformation, they're still making about 5 liters per year increase. And so these are 1998 Lacone, not selected from the top French sheep. So my expectation, and it's just an expectation, is that the current Lacone genetics would be very close, maybe even exceeding the East Frisian genetics that we had in milk production. But I'm just guessing there. Of course, the real advantage of the Lacone, of course, is in composition over the East Frisian. They had higher percent protein, higher percent fat over the East Frisian. The disadvantage of the Lacone is in lamb production. The East Frisian excels for that. The last thing I've got down here on this is hybrid vigor. How much increase in production can we expect from a true F1, say a Lacone East Frisian cross? And our estimate from this data is about 42 kilograms of milk increase from the F1 compared with straight breds, with some increase in fat and protein yield. No effect on percent components, which is the same as the dairy cattle data would indicate. No effect on somatic cell count, and we get a boost in number of lambs born from having F1 ewes in the system compared to purebred ewes. A little bit on lamb growth. Here the East Frisians were no different in birth weight or 30-day weight. That's when we wean the lambs from our artificial rearing system. And the Lacone had somewhat poorer growth rate than our non dairy sheep, and so the Lacone would be somewhat inferior in growth rate compared with the East Frisian. We see some positive heterosis. If you've got an F1 lamb, they have heavier birth weights, they have heavier weaning weights. And if you have an F1U producing those lambs, this is maternal hybrid vigor, an advantage of a lamb to be born from a crossbred mother. They're also heavier. There's no effect on 30-day weight, which you might expect since all of these lambs are artificially reared. So the mother doesn't have much effect on the weaning weight of that lamb under an artificial rearing system. Okay, so in summary on our dairy sheep breeds, how much better are dairy sheep breeds than existing meat wool breeds? A lot better. And we still have people in the U.S. that say, I'm milking Icelandic ewes and it's really great milk, or I'm milking Tunis ewes, but they aren't going to make any money milking those kind of sheep. We need to have dairy genetics in our dairy sheep. There are differences between our sample of East Frisian and Lacone. East Frisians produce more milk, give birth to more lambs, and the lambs grow faster than the Lacone. Lacone have a higher percentage of milk fat and milk protein, and our data indicates, as we would have guessed beforehand, that crossing East Frisian and Lacone should result in positive hybrid vigor for milk, fat, and protein yields, litter size, and lamb growth, but not for percentage fat or protein. This just gives you a little bit of an idea of the composition of our ewe flock over time. Over here is percent breeding. The dark line is percent East Frisian. The light line is percent Lacone. And as I said, we were able to bring in those 6 rams early on, but then we weren't able to get any more Lacone semen in. And so in 2014, our flock on average was 55% East Frisian, 35% Lacone, and 10% non-dairy. But again, realizing tremendous variation within the flock in composition, breed composition. Weaning systems. And is Craig still out there? Craig? I'm just going to ask you to give me the high sign when I need to wrap up here. Give me the high sign for 5 minutes or so I don't run over. What are the effects of different weaning systems on ewe lactation performance and lamb growth and survival? And this was one of the very first studies that we did. When we started out, we were weaning these lambs from their mothers at 30 days of age and then starting to milk. And this is much like the Roquefort system. But of course, we all know that the dairy cow system is to take those calves off immediately and milk that ewe from day one, which makes sense because these ewes will peak in lactation at 3 to 4 weeks after giving birth. And so by allowing those lambs on these ewes for 30 days, we're missing the peak of lactation. So we compared 3 weaning systems. The first is what we call the day one, DY1. Lambs were raised on milk replacer after being with their mothers for 24 to 36 hours to nurse colostrum. The ewes were then milked twice per day for the entire lactation. The lambs were weaned to dry diets off of milk replacer at 30 days of age. We had what we called, well, let me go to the next one, and then I'll come back. We had the day 30 system, where the ewes raised their lambs for the first 30 days. We weaned the lambs then directly onto dry diets from their mothers, and then the ewes were milked twice per day from 30 days to the end of lactation. And then we had what we called the mixed system, where we tried to get some milk out of the ewes, but also have the ewes raise their lambs. And so for the first 30 days, the lambs were separated from the ewes overnight. The ewes were milked once per day in the morning, and the ewes were returned to their lambs for the day. the lambs were weaned to dry diets at 30 days. So we milked these ewes once a day during the first 30 days, and then twice a day after their lambs were weaned. So we didn't have any cost in raising the lambs on the mix system. Here are the important parts of this, not unexpectedly. We got the most milk out of the day 1 ewes, the second most out of the mixed ewes, and the least out of the day 30. Now, realize that this is early on in our dairy sheep husbandry, and so these milk levels are quite a bit below the 390 kilos that we averaged with day 1 ewes at the end. We're still in learning about how to manage dairy sheep, how to feed them, etc. Fat yield was, over the entire lactation, was about 5%, but there were some significant differences here between the day 1 ewes at 5 and the mixed system at 4.5, and that occurred primarily due to the fat content of the milk out of these ewes during the first 30 days. And look what happened. During the first 30 days of milking, we had 5% fat out of the day 1 ewes, less than 3% fat out of the mixed ewes. So what in the world is going on there? Sam Peterson knows, a good lactational physiologist, but it was kind of new to us. We did subsequent detailed studies with oxytocin, where we blocked oxytocin in some ewes, administered oxytocin in other ewes just before milking. And subsequent studies showed that mixed and day 1 ewes showed that the low fat of mixed ewes was due to the failure of oxytocin release and milk down during the milking period. These ewes knew after that morning milking they were going to be put back with their lambs. And so they didn't have full milk let down in the parlor. We captured the cisternal milk that Adrian talked about yesterday, and we didn't get milk let down due to oxytocin release, which is the alveolar milk, and most of the fat resides in the alveolar milk, and it needs active expulsion in order to obtain it. And we just assume that the mixed ewes then had oxytocin release and milk down when reunited with their lambs, so the lambs got all that extra fat. So this was not good news for cheese makers and yogurt makers because of that low fat content. We even tried to feed some supplements to try to cure that. We did another study where we fed Megalac, which is a protected fat, to these ewes, to both the mixed and the day 1 ewes, and we had milk fat increase by 1.9 percentage units in the day 1 ewes, which is a tremendous increase in fat content of the milk, but it had absolutely no effect on the mixed ewes. So they were really hanging on to that fat and waiting for their lambs. A little bit about the lamb growth, and again, I think on a previous slide you saw we only had about 50 ewes in each of these 3 treatments. And so even though there were some fairly big differences in lamb mortality from birth to 30 days, these weren't statistically significant. But I think they're large enough to pay some attention to them. And there's no doubt that Mama did a lot better job of raising those lambs than we did under artificial rearing, although we're pretty happy with a 6% death loss on artificially reared lambs. But those mixed lambs, and you have a fair number of triplets with these East Frisian crosses, and just allowing the ewes to be with those lambs half the day probably wasn't enough for some of those triplet lambs to get enough nourishment. And so that was even reflected then in the mortality from birth up to 120 days of age. Again, not statistically significant, but there's some differences here that indicate that this day 30 system is a lot better for the lambs. And also an indication with 120-day weights. The heaviest lambs at 120 days were the day 30 lambs, followed by the mixed lambs, followed by the artificially reared lambs. Okay, weaning systems. Answer, milk yield, day 1, mix, day 30. Percent milk fat, the day 1 was significantly higher than the mix during the first 30 days. For the entire lactation, there were no significant differences between day 1 and day 30, but day 1 had slightly higher numerical levels. Again, there was no significant difference between the day 30 and the day mix over the entire lactation, but the day 30 was numerically higher. And of course, the day 1 over the entire lactation had significantly higher fat content than the mixed system. Lamb weights, day 30 was better than the mix, which was better than the day 1. Lamb survival, again, there were no significant differences, but just numerical numbers. The mixed system was the worst, and mama raising the lambs did the best. However, when we figured in everything, the cost of raising the lambs, the value of the milk, the labor that went into it, given the prices and costs at the time of the experiment, the most economical system that had the greatest net returns was the mixed system, even with the higher lamb mortality, because we didn't have the cost of raising these lambs. Second was the day 1 system, where we got the most milk, and the least net returns came from the day 30 system. Milking intervals. The last 4 or 5 years, our emphasis has been on milking intervals in ewes. How often should a ewe be milked in a 24-hour period? And we know there are trade-offs there. Shorter intervals between milkings may increase daily milk yields, but it also will increase milking labor. Longer intervals between milkings may decrease milk production, but it'll also decrease labor requirements. So what are the trade-offs here? One of the first studies that we did was 3 times a day milking. And notice here that we had 125 day 1 ewes in this study, and our 53 were milked 3 times a day, but we figured, I should say that the vast majority, almost all of our dairy sheep operations are family-run operations. And we figured that none of these families are going to want to milk on an 8-hour interval. So we had all 3 milkings during the day, no night milking. So we milked ewes at 6 a.m., again at noon, and at 6 p.m. So we've got a 12-hour interval here from night to morning, and then we've just got 6-hour intervals in between the other milkings. And this was applied for the first 30 days of lactation. And the difference in milk production over those 35 days was 95 kilos 3 times a day, 83 kilos twice a day, which is a 15% increase. And that's about the increase that our dairy farmers get with cows with 3 times a day milking. And we calculated, given our labor, that it paid to milk those ewes 3 times a day to get that 15% increase. The interesting thing is the 3 times a day ewes peaked here higher than these, but at 7 weeks of lactation there was absolutely no difference. So this increased peak from 3 times a day did not result in greater milk production through the rest of lactation. So then we said, let's go the other way. Let's try to extend the milking period during late lactation. We haven't gotten brave enough to extend the lactation period in the first milking intervals during the first part of lactation yet. So we said, let's milk 2 times per day or 3 times in 2 days, every 16 hours. So we had third parity East Friesian crossbred ewes. They were as similar as we could get them to be, and we started this experiment at about 90 days of lactation. So we had the twice a day group, 6 a.m., 6 p.m., 24 ewes, and then we had 24 ewes that were milked at 6 a.m. today, 10 p.m. tonight, and 2 p.m. tomorrow. And then the third day, 6 a.m. in the morning, 10 p.m. at night, and the fourth day, one milking at 2 p.m. So we had 45 fewer milkings with a 16-hour interval. We measured milk production at the 6 a.m. Milking, and you can see here that the 16-hour ewes can respond by producing more milk. Their udders are capable of holding some additional milk than the 12-hour milking will, then the 12-hour interval will produce. The question is it enough to compensate for the longer interval? And the answer is yes. When we converted all that to a 24-hour milking interval, there's absolutely no difference at all between those in total milk yield between those that are milked every 16 hours and those that are milked every 12 hours. Now, why would anybody want to milk ewes at 10 o'clock at night? Again, these are family farms, and they have young kids, probably the same here. They have after-school activities at night. They have sports games and stuff. And with a 12-hour milking, mom and dad are milking ewes, getting ready to milk at 5 o'clock in the evening, milking ewes at 6 o'clock at night. With this every 16 hours, they milk at 6 o'clock in the morning. They don't milk until 10 o'clock at night. So they go and see the kids in their after-school activities, but then they come home and milk sheep at 10 o'clock at night. The next day, they milk at 2 o'clock in the afternoon, so they're done with milking before the kids' activities. So we did have some producers that had kids of those ages that did go to this 16-hour milking interval. Once the kids left home, they went back to milking ewes every 12 hours because they didn't like that 10 o'clock night milking. Okay, let's push it further. What about milking ewes just once a day during the end of lactation? So in this study, we had 72 ewes, 24 per treatment. We had the control group twice daily in late lactation, so 14 times a week. We had once a day, 7 times a week. And then I thought, let's push this a little further. Sunday is the day of rest, so let's milk ewes once a day, but don't milk them on Sunday. So we milk them on Saturday at 6 in the morning, and we milk them again on Monday at 6 in the morning. How do these ewes respond to that? We did this study for over 67 days, from day 100 to day 167. So we had 134 milkings with the twice-a-day group. We had 67 milkings with the once-a-day group. And we had 6 milkings with the not on Sunday group. Here are the first two groups. Twice a day in blue, once a day in yellow. And you can see there's not much difference. And this is our days down here. The last 2 points had 2 weeks at the end of the study where we moved everybody back to twice a day milking just to see if there were any residual effects of our treatment. And of course, those 2 groups came right back together. But they weren't much different anyway. This is the total milk yield of once a day versus twice a day, and there's only 4.5 kilos, 4.5 liters of total milk production difference there, and it's not significantly different. One thing that I cannot explain, I'm not a lactational physiologist, and I haven't had one explain it to me yet, and you'll see this later, we get, with extended milking intervals, we're tending to get higher percent fat and higher percent protein compared with twice-a-day milkings, which, of course, is another advantage. Okay, here's the superimposed on this is not on Sunday milking. So down here, this is no milk on Sunday. The first thing, and here's milk on Monday. So these ewes respond on Monday with a lot more milk than anybody else. But you'll notice very quickly that if this is our baseline, they don't go as high above this line as they go below it. So they aren't capable. These ewes, even in late lactation, they are not capable of storing 48 hours of milk, even in late lactation. The other thing that's very interesting here is on Tuesday, they really drop. Look at every one of these, a big drop. They slowly come back Friday, Saturday. They come back to the other groups. But you'll notice here, the Friday, Saturday gap gets bigger as you go through here. This suggests to me that we're maybe doing a little damage to this udder by trying to force 48 hours of milk into that. However, I don't think it's, at least in this study, it's not long-term, because the 2 weeks after, when we put everybody back on twice-a-day milking, the groups have come back very close to one another. But we do get then significantly less milk by just eliminating one of these once-a-day milkings during late lactation. But again, we get a higher percent fat and protein percentage in that milk that we harvest. One thing that we did do later in the experiment, we tried to get some idea of whether or not we're doing some damage to this udder. And of course, in the udder, you've got these very tight linkages between the blood supply and the milk supply. And if there's a lot of pressure in that udder, you can disrupt that linkage, and you can have some blood leak into the milk, and you can have some milk leak into the blood. And so we did look for plasma, we looked for lactose levels in the plasma. And we did have, even though there's a lot of variation here, there was no significant difference in plasma lactose levels between the first two groups, but significantly higher lactose levels in the plasma of those ewes. And we did this just before milking on the Monday, when that udder would be extended to the greatest amount. So it is an indication that we may be doing some damage to that udder by extending that time out 48 hours. So we've done little bits and pieces here. We've looked at 3 times a day milking, every 16 hours, once a day, but we haven't put it all together into a total milking system. So what might be the optimum milking interval for dairy sheep to optimize milk production and optimize labor? Well, I thought maybe during the first 45 days, maybe we should milk 3 times a day. During mid-lactation, twice daily. And then during the end of lactation, go to once-a-day milking. So we had a larger trial taking a look at this. And so we had 36 ewes on each of these 2 treatments, the 12-hour interval versus the optimum system. I'll call it the 3-2-1, 3 times a day, twice a day, once a day. These ewes lambed from January to February, which is right as our normal lambing time, which is right in the middle of winter. They were put to milking immediately after lambing, and they were milked 208 days. We had 36 ewes on twice a day, milked at 5 a.m. and 5 p.m. We had the optimum, 36 ewes, for the first 40 days. We didn't get to the 45 I had before. It ended up being milking the first 40 days, 3 times a day. 5 a.m., noon, 5 p.m., like we had, somewhat like we had done with our previous one, not true 8-hour intervals. Then 98 days, we milked twice a day, and then the last 70 days, we milked once a day in the morning. Number of milkings, we had 416 milking bouts with twice a day, and we had 386 milking bouts with the 3-2-1 system, a decrease of 7.2% in milking labor. Okay, what about 3 times a day milking? During the first 40 days, we did get a significant increase in milk yield. It's interesting here again, the ewes that are milked less frequently, we had a higher percent fat than those ewes that were milked more frequently. No significant difference in protein, no significant difference in somatic cell count. However, in the earlier study, we got a 15% increase in milk yield from 3 times a day milking. Here we only got a 9.3% increase in milk production from 3 times a day milking. During mid-lactation, again, no difference in milk production between those 2 groups, although maybe there's a little carryover here. We saw 7 liters more milk on average in the ewes that had previously been milked 3 times a day, even though everybody's now being milked 2 times a day, but I can't read much into that since it's not a statistical difference. We had a carryover in the fat percentage, favoring those ewes that had been milked 3 times a day previously. We're very pleased with the somatic cell counts. I mean, this is less than 100,000 somatic cell count in these ewes. Both groups milked 2 times per day in mid-lactation. The ewes previously milked 3 times per day produced slightly more milk, as I've indicated, but the difference wasn't statistically significant. What about late lactation? Here, I guess I was a little disappointed. Maybe if once you get the results that you think you should have, maybe you shouldn't do another experiment. But it's always good to replicate your data. We did get a significant decrease in milk production by going to once a day over continuing twice a day during that last 70 days of lactation in this trial. Again, with the less frequent milking, higher components than a higher fat and protein percentage than with more shorter intervals. So these results differ from the previous trial in which there was no negative effect of milking 1 time per day in late lactation. So where does that leave us on total lactation? No significant difference in any of the factors here. With this 3-2-1 system produced the same total yield of milk, similar fat percentage, similar protein percentage as the 2 times a day. So the advantage is we had 7.2% less milking labor involved in this system than this one. Very good. I've got the high sign here. So we'll question, how often should ewes be milked in a 24-hour period? The answer is milking 3 times per day during the first 30 to 40 days of lactation from our work. And this is with no true night milking, so they aren't true 8-hour intervals. Our result says that you might get a 9 to 15% increase in milk yield. Milking 1.5 times per day every 16 hours during late lactation may not result in a decrease in milk yield during that period. Milking 1 time a day during late lactation may result in a 4 to 12% decrease in milk yield during that period. A milking interval of 48 hours, even once a week in late lactation, from our data, will significantly decrease milk yield and may compromise udder health, and we don't really know if that is totally long-lasting. In our data, it suggests that it probably isn't. At the end of that lactation, they responded right back to the other ewes when they went back to twice-a-day milking. However, the bottom line, milking once per day in late lactation, given the economics and the cost of our milking labor, should result in an improvement in net income if paid milking labor is used on the farm. If you're using mom and the kids to milk those ewes and it doesn't cost you anything, then there's probably not any effect there. I do have a little bit on some of our grazing work and supplementation, but maybe I'll go through just one of these. We have, I heard a lot about yesterday hybrid systems, and that's what we have. During the winter, we don't have any choice but to have these animals housed and fed stored feeds. But during the pasture season, our ewes are on pasture. And early on, in 1996, 97, 98, we thought that we should be in a dry lot system. But we had an agronomist there that had established some beautiful Kura clover orchard grass pastures that we said, we need to be using these pastures. So we took a small group of ewes and we put some of them out on these pastures. The other stayed in dry lot on alfalfa hay. And sure enough, we got 11% increased milk production from the grazed ewes. And so from that time on, pasture during the growing season has been our primary feed source. So what's the effect of grain supplementation of grazing ewes on lactation performance? And this was a study that was, for the scientists here, it was a 2x2 factorial. We had a group of ewes on pasture in May that had just lambed, so they were in early lactation. And we had another group of ewes that had lambed back in January and February, went to pasture in May, so they were in mid to late lactation. And our hypothesis was that we might get a response to grain supplementation in the early lactation ewes, but not in the late lactation ewes. Well, that didn't happen. There was no interaction. We got the same response whether these ewes were in early lactation on pasture or late lactation on pasture from supplementation. And our supplementation was 2 pounds in the parlor, or 0.9 kilos, about 0.45 kilos in the morning milking, 0.45 kilos in the evening milking of a 16 crude protein supplement. And over this period of time on pasture, we got about 1/4 of a liter more milk per day out of the supplemented ewes than the unsupplemented ewes. And I've put both the late and early lactation ewes together because they both responded the same. And you can see here our milk price is about $1.80 a liter. So we got about 45 cents more milk income from those ewes, and it cost us something less than 13 cents to get that 45 cents of milk. So it paid. In our situation, with our grain prices, it paid us to supplement these ewes. The one bad thing is that these really good pastures we had were about 22% crude protein. We didn't need this 16% crude protein up here, and we had very high milk urea nitrogen levels in the milk. We'd like to see that at 20 or below for proper nitrogen or protein efficiency. And I know nitrogen going back on the land is a real concern here. It is in the U.S. Also. So I'm going to skip ahead to one last study here that, and then I'll finish up. This is the effect of alfalfa and orchard grass on performance of dairy ewes. We knew that if you put legume in the pasture, you're going to have better performance. But the question was, how much? So we first did a stall feeding cut and carry study. This is my graduate student Claire, that early in the morning she went out with this little mower and she got enough lucerne, alfalfa, and enough orchard grass to feed these ewes in dry lot. And so we had rations that were no alfalfa, 100% orchard grass, 25% alfalfa, 75% orchard grass, 50-50, up to 75% orchard grass and 25 or alfalfa and 25% orchard grass. Then the next year we did a grazing trial, and so we had pure strips of alfalfa and orchard grass, and then we penned them so that the ewes would have land area equivalent to 100% orchard grass, or they'd have a quarter of a strip of alfalfa and 75% of a strip of orchard grass, or 50-50. And we used some markers, and the ewes actually ate very close to what the area of land that was in each of those. So, not surprising, as we increase, here's the cut and carry, here's the grazing trial, as we increase the amount of legume in the diet, we increase milk production in the cut and carry thing up until 50% legume. There was no response going up to 75% legume. And of course, with the grazing trial, we got similar results. So, have legumes in your pastures to get more milk production. With that, I think I'll end, and I thank you for your attention.
So I think we have time for a couple of questions, and Jolin's got some microphones he can pass around. So if you just got a couple of questions you'd like to, and then we'll have some morning tea if somebody would like. Thank you, Dave, for that. Yeah. So just one question. Where is the US sheep dairy industry at right at the moment?
Yeah. The question was, where are we at with the dairy sheep industry? We're a small industry. It's growing, but it's growing slowly. There are no national figures kept on the number of dairy sheep, the amount of sheep milk produced, but we estimate that there's maybe approximately 200 dairy sheep farmers in all of the U.S. The largest flock is a flock of 2,000 ewes at Shepherd Way Farm in Upper State, New York. Most of our farms are 150 to 200, maybe 300 ewes, and the main use of the milk is for artisan cheese. So a fair number of our dairy sheep producers are also sheep milk processors and sheep milk cheese marketers. I would say probably a little over half of our dairy sheep farms are also making their own cheese, and a little less than half are producing milk going to a local cheese plant. So we're growing, but we're growing at a fairly slow rate.
Great. Sam.
Dave, peak lactation.
Yeah.
You early in your talk mentioned 3 to 4 weeks, but one of your trials for the 2 times versus 3 times indicated a peak lactation occurring in the 2nd week, which is when I find a peak lactation in my Romneys here in New Zealand. Would you like to comment?
Yeah. Was that first one? Was it? It was. Yeah, I guess it was at about the 2nd week that we actually peaked. I think that trial was done very early when we had a higher proportion of non-dairy breeding. So given your results, maybe it's not that unusual. But our peak lactation in our higher percentage dairy sheep occurs in that 3 to 4 week period.
Thank you.
Thank you.
A comment and a question. It seemed to me that those sheep that didn't let down were physiologically pretty smart. You know.
Yeah, they are. Yeah.
In the non-milking on Sunday
Yeah.
protocol, you talked about the tight junction leakage, and Maristella's published some work about lactational continence. Did you see that as well? Where they were just losing the milk in the paddock?
We didn't notice that with leaking udders. Yeah, we didn't see any noticeable leakage of udders in those ewes. So they evidently have a pretty tight teat sphincter.
Okay, so I wonder if we can have another round of applause for Dave, because he's come a long way and asked us all to. Thank you, Dave.